Hello everyone. So in the last video we have seen some very popular neural network. One is the AlexNet, another is InceptionNet, and we have seen many other listed here. Now big question came in our mind, like if we want to solve some problem, can we train such a big complex network in our simple laptop machine or desktop machine? So the question is no, we cannot train such a complex network. So then again another question came in our mind, how we can utilize this network to solve our own problem, right? So then another new concept is coming into the picture, that is known as the transfer learning, right? So let's see how the transfer learning help us to solve multiple problems, right? So before jumping into the details, let me give you an idea. Like in our education system, whenever we start our education, in like we start with the nursery class, then first class, then second, third, fourth, fifth, then we come to the intermediate. Now after intermediate we decide which stream we want, which kind of course we want. So some person likes go to the BTech, some person likes go to the BA, some person like go to the BCom, some person like go to the some other courses, BBA, or many other courses as well. But once they enter into these courses, or suppose you enter into the BTech, is whatever you understand from nursery till 12th, is that will never utilize? No, it will utilize, because your basic building blocks start from very first class. So in the nursery we understand the alphabets A, B, C, D and all, and then words, letters, and they form many things. Means we start from very fundamental, the very elementary things that we required anyways to taking the bigger decisions, or you can say to solving the bigger challenge. Then those fundamental things will carry forward. Then in the first class we understand the some maths, some other things like summation and difference, multiplication. So those all things, and then slowly we move forward. Then in the intermediate we looks into the more detailed maths and other things. But these all things are playing very important role to become, or to complete our BTech successfully. Or once you done the BTech, maybe if you are looking for the postgraduate program, then your BTech will help to find out or to make you successful in the MS program or in your job, right? So it doesn't mean whatever we understand previously that is not utilized at all. But same thing happened with the neural network as well. So in the neural network, initial layers are responsible to finding the basic features, or you can say elementary features. So now you can say we have elementary features like age of in the image, ages, or you can say colors, or those kind of elementary features. And as we move forward in the more forward layers, then we are combining those basic features and clubbing them together and finding complex features. At the end, once we club all those complex features, we'll get our final results. So ultimately the feature extraction part starts from very basic. So why we are taking this example, suppose we are trying to solve a ImageNet challenge where we have 1000 classes of like you can say dogs, cats, and human, computer, and many other classes. But in order to classify those objects also, initially we start from the same place where we extract the ages, we extract the colors. Now suppose I want to solve a problem that is the related to the medical domain, where we want to identify the cancerous versus non-cancerous cell. Again, the elementary part from where the initial layers will start, they again start from the color, they again start from the ages. It means If a network is trained on ImageNet, at least their feature extraction part can be reutilized and you will get some good results. It means you do not need to retrain the entire network, but the later you can say later layers will be trained, that will be, maybe you will get a very nice results. So let's see, and this entire concept is known as the transfer learning. So let's see some examples with the help of PPT, how much we need to train and what is good whenever, or how much data we have. So how we'll make that decision, let's look into the detail. So the first thing, very important, that is open source implementation. So we can say we are utilizing the pre-trained weight, but how we'll get that weight? So getting that weight, you have to thankful for the open source implementation. So the entire community help us to find out those solutions. So suppose one person trained AlexNet, so they put it in the open source so that others can utilize it and try to solve their own problem. So open source really help us to find out many solutions. You can see in the GitHub. In the GitHub you will get all variety of weights and their models, right? So you can utilize it, clone it and solve our own problem. Now let's understand the transfer learning. So what transfer learning is saying, as I discussed, they are very important driver in the deep learning, because everyone do not have that much computation power so that they can train a deep neural network from the scratch, right? So what they are doing, they are taking the pre-trained weights from the existing network, and these pre-trained weights can be utilized as the feature extraction part, and then we are trying to solve in other domain as well. So for example, I am trying to solve classification problem, but not the in general classification of the 1000 class. We are trying to solve the classification problem, maybe the leaves. So you can say tomato leaves or rose leaves or other leaves. So then for that also you have images, you have to extract the features, and then based on that features you will start the classification. So your initial feature extraction part will help us to solve the problem. So you can say how much we can train. So if you have very small data, so for example, maybe you are trying to solve some medical related problem and you have very small data. So in that case, what you will do, you will take pre-trained weights from the previous, or you can say these well-known challenge or well-known models, and you will add your own layer at the end by removing last softmax layer and maybe some fully connected layer, and you add your own fully connected layer and softmax layer, and then you train only this part from your data. So once it is trained, it will give you the results based on your new problem. Now it will be no more the 1000 class classifier. You have removed the softmax and added your own foxmax, maybe that has only 3 nodes because it's a 3 class problem, and then you will train only this part. You will train only this part. So with this small data you can train the smaller part, and that is the beauty behind the transfer learning, right? So this network will extract the features and this network will train on your data, and that will give you the appropriate result. So instead of having nothing in hand, with less amount of data you can train few layers and you will get a good nice result. Getting? So now if you have mid size of data, so then you will think of improving the accuracy further. So what you will do, instead of training only last layer, you will train few more layers, so that these layers will also be very specific for your problem. So in that way, if you have mid size of data, then you will train more layers. And if you have enough data in hand, and if you have enough computing power in hand, then you can train the entire network from the scratch. In that case also you can utilize those pre-trained weight. So you can say from where we can start the network. So suppose you have taken the LXNet architecture or VGGNet architecture to solve your own problem. Now you say I have enough data, I can train from the beginning. So in that case, what you can do, we can use their existing pre-trained weights as the starting point, right? So you say once you utilize this starting point, so you are not started very random. So your network already trained to find out some appropriate features from the data. So this will help you to train much faster on your own data, and it will adopt much faster. So your model will converge much faster. So in that way you can utilize the pre-trained weights. So I hope now you can think of any problem and try to solve it using the transfer learning. Now as you are not training the entire network, if you have a smaller data, you can utilize your own laptop, or if you have only one single GPU card, then also you can train the partial network, right, very easily. Or you can use some open source tools as well to train your model, such as Google Colab or other open source models that will help you to solve these problems. And you can solve your own problem even if you do not have huge supercomputer to train from the scratch. So that's the beauty behind the transfer learning. Okay guys, so now you are ready to train your own model. Now you can train your own model for any classification task. So try to think of and what different modification you will do so that your existing model will solve your own problem. Okay, and then in the next video we will try to look into a different variety of problem in the vision domain. Okay guys, so we'll catch you in the next video.